Welcome back for part 7 of the trig lesson for Dr. Murdoch's pre-calculus class. We are on part 7. Part 6 was a video that used the pathways e-text in the background. But we're going to move along, and so this is our probably our major theme of the lesson. We want to be able to solve equations that involve trig components. And we're going to end up solving 2 times sine of theta plus 3 equals 4 and find all real values of theta that make that equal sign true. Now I'm going to remind you of 2 similar problems. Okay. We've solved a lot of linear equations, and this trig equation is related to this blue linear equation. In blue we have twice some unknown plus 3 gives us a total of 4, whereas in red we have twice the unknown output of sine plus 3 gives us a total of 4. And we know that we need to undo the add 3. So we would subtract 3 from both sides. And then to get u by itself, we do the opposite of multiplying by 2, and we divide both sides by 2 and record the result. Okay. So a lot of our trig functions will simplify down to first solving some linear equation and then solving for the unknown theta. And while we're thinking about it, we've been talking about other transcendental functions, and so I just wanted to show you a quick example of twice this exponential plus 3 equals some constant. And we've used the strategy before where we try to isolate the transcendental function if we can on one side of the equation. So I showed the result of subtracting 3 from both sides, and I showed the result of dividing both sides by 2. And so in this example, I need e raised to some unknown power to equal 1. Well, by inspection, we might notice that x needs to be 0. E to the 0 is 1. But I wanted to point out how we use inverse functions. I'm not showing the whole right-hand side, so I'm just going to scoot this over. But to go from line 3 to line 4, even if we don't write it down, we're applying natural log to both sides of the equation. And natural log of an exponential simplifies down just to the exponent of the exponential. And natural log of 1 is 0. Okay. So moving right along, back to our trig equation. First, we want to isolate the transcendental part. So we subtract 3 from both sides. We still want to isolate the transcendental part of the left-hand side. So we want to undo multiplying by 2, and we'll show the result of dividing both sides by 2. Okay. So this is the simple trig equation I showed you at the beginning of video 1. Okay. Now, if we use our calculator, and this may not always be the way to go, but we can approximate theta by applying inverse sine, or arcsine, to both sides of the equation. So I'm going to apply arcsine to sine of theta, and I'm applying arcsine to positive 1/2. So this is symbolically how we would solve the equation. Let's see if I can show you the whole, yeah, there we go, the whole line. Now when we apply an inverse to a function on its restricted domain, we'll get a unique solution for the unknown. Okay, so I've used my calculator ahead of time, and I get approximately 0. Let me hold on. Sorry guys. Sine inverse applies to sine theta will reduce to just the argument theta. So it's kind of a cancellation. But when you compose 2 inverse functions, you end up with the identity, and you're left in this case with theta. Now on the right hand side is where I've used my calculator. So I get approximately 0.539. I'll check that again while we go along. I'll pull up my calculator here. I seem to have let that go when I was in the middle here. Okay, so since the time is still ticking, let me finish up this one example. Using the unit circle, we would have found the exact value of theta in radians, pi over 6. Okay, and if you remember the graph of sine, okay, there was only one value of theta that would give us an output of 1/2, and that was pi over 6. So now to finish this problem, we're going to have to talk about the remaining values of theta that satisfy the original equation, where theta could be any real number. And so just to preview, to finish this equation, not only do we need that first value of theta that is part of sine's domain from 0 to 2 pi, there's a second value of theta on that first cycle of sine from 0 to 2 pi that's